Okay, so in this problem, we're told Huck Finn walks at a speed of 0.7 meters per second across his raft. That is, he walks perpendicular to the raft's motion relative to the shore. The raft is traveling down the Mississippi River at a speed of 1.5 meters per second relative to the riverbank. What is Huck's velocity, speed, and direction relative to the riverbank? So, first thing that we got to do is understand what's going on. So we have Huck here, and he's going to be walking straight at 0.7 meters per second on his raft. While at the same time, the river is going to be pulling him 1.5 meters per second to the right. So we're going to be finding his speed, or the velocity, relative to this point. And so the first thing we need to do, or to do that, we need to understand is I'm going to denote this as the y-axis. So this right here is going to be your y, and then this right here is going to be your x. So he's going to be walking with a velocity of 0.7 meters per second this way, and he's going to have a velocity in the x of 1.5 meters per second. So now what we want to do is understand his speed in each direction relative to that point, or to basically just something not moving. So if we look at it first starting in the y, we can say v of y, and this is going to be a vector, it's going to be equal to 0.70, and then we're going to use the unit vector symbol, j had. So this is the unit vector in the y direction. So we would basically say, and then we can also denote the units meters per second. But essentially, relative to this point, think about his velocity in this y direction. He's going to be traveling 0.7 meters per second this way, and this right here doesn't affect his velocity in the y. So his change in the y is 0.7 j had, and this is going to be meters per second, and it's basically his velocity in the y. And so now what we want to find is his velocity in the x. So in the x, it's going to be, notice relative to this point, he's moving 1.5 meters per second every 1.5 meters every single second. So v sub x would just be 1.50, and then I hat is what we denote for the x, and then this would be meters per second again. So you basically have his velocity in the y is 0.7, and then 1.5 is his velocity in the x. And so keep in mind, we label them positive because I'm just denoting upwards is positive and to the right is positive. So down would be negative and left would be negative. But in this case, these are going to be the components of his velocity. So you could write v, the vector v, which is the velocity, and we can just add the components up. So he's moving at 0.7, or let me write it this way, 1.5 I had plus 0.7 j had, and then the units are meters per second. So this is the speed at which the velocity is moving. And they want us to write it as speed and direction. So instead of leaving it in this component form, what we're going to do is find the magnitude of it. So we're going to basically find his speed and the direction it is relative to the horizontal, because that's what they want us to find. So let's go ahead and do that now. So if you have the components like this, the way you do it is v is equal to the square root of vx squared plus vy squared. And so you kind of imagine it like a triangle here. If this is vx, or let me draw that better. If this is vx and this is vy, and then this is v, right, the magnitude of these two components, it's just Pythagorean theorem. So you should know a, b, and c. So the formula is a squared plus b squared equals c squared. And then c is what we're solving for, because that's the v. So you would just square root both sides. And that's how we get this. So we have that. All we got to do is really just plug in the values now. So we have 1.5 squared plus 0.7 squared. So let me get on my calculator and we can go ahead and plug that in. So second square root of 1.5 squared plus 0.7 squared, you would get 1.655, and then the units are meters per second. Keep in mind, this is the velocity or the magnitude. So he's going to be traveling this way, obviously, because we're going up and to the right. So he's going to go this way with relative to this shore at 1.655 meters per second. You can round to 1.7 or however you want to. We can just say 1.7 meters per second, however you want to write it. But now what we need to find is the direction. So they want us to find both the speed and the direction. So when they're talking about direction, they're basically talking about the angle. And so the way you do that is you take the arc tangent of your x and y component. So you do the y component over the x. So in this case, our y component is 0.7 and 1.5 is our x. So you just do the arctangent of that. And when you do that, you're going to get a value of 25 degrees. So 25.01 degrees, or 02, I guess. So about 25 degrees. And this should make sense because we're obviously going to be closer in the x this way more because this velocity is faster. So if this one was faster, we would be traveling more like this. But since this is faster to the right, we're traveling more like this. But yeah, so the velocity is going to be this right here. You can round however you'd like. And then when they say the direction, it's 25 degrees. And keep in mind what this angle is. It's the angle right here. So this would be your 25 degrees. And that's what they're talking about in terms of direction. So just keep that in mind. So this right here is going to be your answer for the direction. And yeah, so hopefully you found this video helpful.